So I'm making this quick video to kind of clarify the difference between a rate and a rate law. So a rate is like how fast the reaction is going, right? So I'm going to look at number 3 on the practice to kind of show this. Right. So when you're looking at a reaction and you're like, okay, in this reaction, 1A turns into 1B and 4 C's, right? This is a stoichiometric balanced equation. What that means is for the rate of something, since this is a 1-to-1 ratio of A to B, the rate at which A is disappearing is equal to the rate at which B is appearing. So if A is negative 0.105 atmospheres per second, that negative means it's disappearing, then B would be appearing at the same rate because it's a 1-to-1 ratio. Whereas C would be appearing at a rate 4 times that of A because it's a 1-to-4 ratio. So rates, which are going to be in atmospheres per second or molarity per second, are stoichiometric and is based on the balanced equation overall. Okay, so this one is asking for C. What is the pressure change for C if A is negative 0.105 atmospheres per second? Again, that means A is disappearing at a rate of 0.105 atmospheres per second. Since this is a 1-to-4 ratio, C would be appearing at 4 times the rate of A. So it's just this times 4. So anytime you're just doing a rate, you can multiply by the coefficient, just like a mole ratio. So the answer would be 0.420, right? This times 4, because it is appearing at the rate 4 times the rate. That's the easiest way to kind of explain it. So rates are stoichiometric. A rate law is different. So you do need to read questions very carefully. A rate law is more based on the mechanism. So for example, let's still talk about this reaction. If I have this reaction, it could be that, say, I doubled the amount of A that I started with. And usually adding more reactants means more collisions, means more, it's going to proceed faster to the right. Now, if it was 0 order in A, it actually didn't matter about the A, then that actually wouldn't speed it up. If it was first order in A, then if I doubled A, then it would double the reaction rate. Or if it was second order in A, if I doubled A, it would quadruple the reaction rate. So this is like a rate law is like how fast it goes based on how much stuff you have. Okay, and that is not stoichiometric. So rate laws are not stoichiometric. So again, you have to read carefully. A rate law can only be found in 2 ways. The first way is with data. Now, there isn't actually one of these in the optional practice because there's not a multiple choice question on the exam that it goes with. However, there is definitely going to then be a question with a short answer based on it. But I'm going to pull up your assignment that went with this, kinetics. Let's see. Okay, these were the stoichiometric ones. Here we go. Determine the rate law. So the first way to determine a rate law is if I give you data. So for example, I have 4 trials here. If I want to know how it's based on A, so rate law goes rate equals K times whatever reactants. So if I want to find A, I want to find 2 trials where B stays constant. So in trials 1 and 2, B doesn't change. A triples, and then I would be like, okay, what happens to the rate? Well, that triples as well. That means it's going to be first order in A. I know if this tripled in this 9 times, then it would have been second order in A. But okay, I would be like, all right, it's first order in A, and then I want to find 2 where A stays constant. So I would do trial 2 and trial 4. B doubles, the rate doesn't change. That means it's not actually based on B. So the amount of B doesn't affect the rate. So B is 0 order. So I'd be like, okay, well, it's rate equals K times A. That's it. So the only way to find a rate law is, like I said, with data. Oops, not that one. Data, like I just did. The other way is if you have the mechanism. It has to actually be the mechanism. So I'm going to scroll down here because we did some mechanism ones. Okay, here we go. Consider the proposed mechanism for the decomposition reaction from hydrogen peroxide to 2 waters and an oxygen, okay, in the presence of I-. What is the rate law? So if I have a 2-step reaction, the way you do this is you look at the slow step and you'd be like, okay, what reactants are in the slow step? Well, H2O2 and I-. Now this is when you can use, if you have the mechanism, you can use the coefficients of the balanced reaction. So if I said this is a slow step, I would be like, okay, The rate is based on how fast one of these hits one of these. So it would be first order in each. So it is actually based on those coefficients if you have the mechanism, only if you have the mechanism. Okay, so it should be C would be the answer because it's based on both of these. Now, yes, I minus is a catalyst in this case because you can see, oops. You can see in the overall reaction, I minus is going to disappear. So no, it's not a reactant. Catalysts can be in the rate laws, but intermediates cannot. Okay, so if you had a slow step as the second part, you would have to go back and do the substitution thing. Okay, so just kind of as a recap, a rate is stoichiometric. That's the speed at which it's going. A rate law, on the other hand, let me get out of this. A rate law, on the other hand, is written as rate equals that rate at the beginning, that is how fast it's going, equals K, your rate constant, times reactant 1 to whatever power, reactant 2 to whatever power, and maybe there's a catalyst in there, or maybe not all reactants are in there because they might be zero order. So the only way to determine a rate law is with data, multiple trials, or with an actual mechanism. That's the only way. Okay. Otherwise, I have to actually tell you what the order is. So when we start talking about other types of questions, it could be a question with an integrated rate law. Okay, integrated rate laws are what you use when you know the order, and then it's a plug and chug solve for that equation. So if I tell you it's first order, then you can use those natural log equations that are on the equation sheet. If I tell you it's second order, you can use the second order equations that are on the equation sheet. So those are integrated rate laws. Okay, so those are kind of like the three topics we would say would be like rates, rate laws, and mechanisms, and integrated rate laws. Integrated rate laws are the ones that are time and concentration. Regular rate laws are rate and concentration. That's why it's rate equals this time says. So if you have other questions, shoot me a message, let me know. I'm happy to help.